Have you ever wondered how to group different variables together in C++? Well, structures and unions have got you covered. These are user-defined data types that allow you to do just that. Think of them as a way to create your own composite data type that can hold different kinds of variables together. But here's the catch. Even though structures and unions seem similar, they have some key differences. Structures are like a container that holds different variables separately. Each variable inside a structure has its own memory space. On the other hand, unions are a bit more conservative with memory. All the variables inside a union share the same memory space. Yes, you heard it right. They all live together in one place, like roommates sharing a single room. So let's dive deeper into these two fascinating concepts: structures and unions. Consider structures as a blueprint for creating complex data types. They allow us to group related variables of different types together. Imagine you're working on a geometry project and need to represent a point in a two-dimensional space. You could use two separate integers for the x and y coordinates, but wouldn't it be nice to group them into a single entity? That's where structures come into play. Let's declare a structure named point. Struct point $. Here, point is a structure that contains two members, x and y, both of integer type. Now let's create an instance of this structure. Point p1 equals sign at 10, 20. This initializes p1 with x as 10 and y as 20. Now how do we access these members? It's quite simple. Int x value equals sign p1, x. This statement fetches the x coordinate from our p1 point. Structures can also be used with functions. Let's say we have a function that prints the coordinates of a point. Void print point, point p. In this function, we're passing a point as a parameter and printing its x and y coordinates. When we call print point p1, it will print x10, y20. So why are structures so important? They provide a way to bundle related variables together, thereby reducing complexity and enhancing readability. Whether you're working with geometric points, date structures, or even complex database records, structures offer a neat way to manage related data. And that's how structures work in C++. They group related variables and make our programming life easier. In the next scene, we will delve into unions and explore how they differ from structures. So stay tuned. Unions, on the other hand, are a bit different from structures. While structures allow us to group different types of variables, unions take a slightly different approach. Let's consider an example. Suppose we have a union named numeric value. This union contains two members, an integer int value and a double value. The key thing to remember here is that unlike structures, all members of a union share the same memory location. This means that the union's size is determined by its largest member. Now, how do we initialize a union? It's simple. If we have a union numeric value, we can initialize it like this. Numeric value num equals sign 42. This initializes int value, but leaves double value undefined. Accessing union members is also straightforward. If we want to access int value, we simply write num int value. If we want double value, it's num.double value. Easy, right? But remember, only one member of a union can be accessed at a time. Unions also play nicely with functions. Let's illustrate with a function named print numeric value. This function takes a numeric value union as an argument and prints both int value and double value. Of course, only the value of the member that was last stored will be meaningful, as they both share the same memory space. So why would one use unions? They are particularly handy when you want to store different types of data in the same memory space. This can be useful in situations where you want to save memory, or when you're dealing with hardware register manipulation, among other scenarios. In summary, unions are a fascinating feature of C++. They allow us to define a data type that can hold different types of data, but remember, only one at a time, as they all share the same memory space. Unions are quite unique, aren't they? They allow different data types to share the same memory space. Now that we've looked at both structures and unions, you might be wondering what sets them apart. Well, the key lies in their memory usage, initialization, and how we access their members. Let's start with memory usage. In a structure, each member has its own separate memory space. This means if you have a structure with 3 members, each of them will have its own designated space in memory. Unions, on the other hand, are a bit more efficient or risky, depending on how you see it. All members of a union share the same memory space. The size of the union is determined by the size of the largest member. Next, let's talk about initialization. When we initialize a structure, we can provide a unique value for each member. However, the story is different with unions. When we initialize a union, only the first member is guaranteed to be initialized. The values of the remaining members are, let's say, left to the imagination. Now on to accessing members. In a structure, we can access all members independently. You want the third member? You got it. The first one. It's all yours. But in a union, it's a little more restrictive. Only one member can be accessed at a time, and it's usually the one that was last stored. These differences lead to different use cases. Structures are your go-to when you need to group related but distinct pieces of data. Think of a structure as a multi-talented artist, juggling different roles independently. Unions, however, are more like a chameleon, changing its form based on the situation. They're useful when you want to store different types of data in the same memory space, but only one at a time. While both structures and unions have their uses, it's crucial to understand their differences to utilize them effectively. So the next time you're faced with a choice between a structure and a union, remember their unique quirks and choose wisely. Let's put all these concepts into a practical example. We'll be working with a piece of C++ code that uses both a structure and a union. To start, we have this block of code. The statement is a preprocessor command that tells the compiler to include the iostream standard file. This file allows us to perform standard input and output operations, which we'll need later on. Next, we define a structure named with two integer members, and this structure will allow us to store two related pieces of information, the coordinates of a point in a two-dimensional space. Moving on, here we define a union named. This union has two members, and remember, these two members share the same memory space, so they can't be used at the same time. This union allows us to store either an integer or a double value, depending on our needs. Next, we enter the function of our program. In the function, we create an instance of our structure and initialize it with the coordinates 10, 20. We then print these coordinates to the console using. Continuing, we create an instance of our union and initialize it with the integer value 42. We then print this value to the console. The statement signals the successful termination of our program. So there we have it, a simple C++ program that demonstrates how to use both structures and unions. This program represents a point in a two-dimensional space and a numeric value that could be either an integer or a double. With structures and unions, you can efficiently manage and manipulate data in C++. Keep practicing, and soon you'll master these concepts.